Hello and welcome to the WBS 6 briefing. This week we're looking at resources and cost, but primarily resources. And here's the thing. You remember in the first few weeks we identified the scope of the project, we boiled that down through the WBS, down to the work packages where you now have activities. You put your activities in order, you make this nice network diagram, and now you have a clear view of how long the project is going to take. But do you really? Here's the issue. Usually you don't have the resources that you think you have or that you wish you had. And because of that, the network diagram that you've created up to now needs to be reoriented and shifted around to take into account the constraints you have on your resources. Now, also recall that when we did the network diagram, we found activities that had slack in them. Why is that so important? Well, if you're going to have to move around activities because you have limited resources, the first ones you want to move around are those that have slack. But as we'll see, we'll start to use up the slack when we start shifting around activities to take into account a lack of resources. Then when we do that, we find out ultimately the schedule gets delayed. And that makes sense. If you don't have enough people to get the job done in a timely manner, the schedule is going to get delayed. So let's have a look at just some of the highlights from this chapter. We're in Chapter 8 for WBS 6, Schedule, Resources, and Cost. Remember that the network times are not a schedule until resources have been assigned. You may think you have a schedule, and you've had some implicit assumptions underlying that schedule, but you don't really have them until you start applying those resources. Also, you have estimates up to now, but you don't really have a budget, and you won't have a budget until you assign resources. And the reason is, resources are associated with cost. Therefore, when you assign resources to a project, the cost that's assigned to those resources carry over to the project and are attached. Okay, so here is the project planning process. We take the scope, the network diagram, we do resources and cost scheduling. That leads to a master plan, but ultimately that master plan it doesn't come to fruition until we've dealt with the resources. And there's a risk that we can actually deliver due to the constraint on resources. There's really two types of resource problems. One is, let's say you did have all the resources you needed. Still, you need to balance out demand on such resources. For example, you don't want some people working 24/7 for a week or so and then not working at all for a couple of weeks. You need to balance that out for morale issues, for efficiency issues. So resource leveling is really about balancing resource demand. So that is one problem, assuming that you have the resources you need. Then there's resource constrained scheduling where you don't have enough resources, and so you have to shift around tasks to take that into account. Okay, so let's jump down to a couple of other key themes here. You have to decide first, do you have a time-constrained project or do you have a resource-constrained project? If you have a time-constrained, then you try to add resources to the degree that you can. If it's a resource-constrained project, then you may need to slip that schedule out, and most often you do. Time-constrained, you got to complete by an imposed date. You will be balancing resource demands. You're going to try to use up the slack that you have available, but ultimately that project will likely end up being delayed if, depending on how severe your resource constraints are. Let's take a look at this slide. Here's a couple of problems. This is a botanical garden development. Notice you have different activities on the left here: design, layout, and scarify. That's to level out the land, walkways, lighting, irrigation. And the resources in this case are backhoes. You go from 2 backhoes to 4, down to 1, down to 3. In this case, this is a case of resource leveling. If you were a construction company, chances are you wouldn't own those backhoes. You would probably rent them. So you wouldn't want to rent 2 and then 4 and then turn back in 2 and then go to 3. Here you smooth out your resource demands. For one thing, it simplifies things. And then secondly, you reduce the peak demand. And peak demand is something that you want to reduce. Now, let's look at an example of a resource-constrained project, a little bit more complicated one. Now, when you have a network diagram, which you've done that up to now, and you start applying resources to them, you're going to have a priority of what resources what task you schedule based upon resources you have available and how important that activity is. And there's rules of thumb used to schedule activities. First of all, when you're going to apply resources to tasks or activities, the very first thing you think of is which activity has the least slack. If it doesn't have much slack, for example, if it's on the critical path, you want to apply resources to that first so it doesn't get delayed. Remember, activity on the critical path, if it's delayed, it delays the entire project. The next rule of thumb is you would focus on applying resources to an activity that has the least duration. The rationale behind this is if the duration is very short, you can just get it done and move on to others, as opposed to tying up resources for a very long activity. And then finally, schedule the lowest activity identification number. You may wonder, what's the point of that? Well, remember, identification numbers go from smallest to largest. So if you have a low activity number, if you get that done, oftentimes a low activity number is a predecessor to a later activity, so you can go ahead and knock that out. Here's an example of a network diagram. The durations are on the bottom. For example, activity 1 has a duration of 2, activity 2 has a duration of 6, etc. And you see the amount of people that are required for each activity in the center of each block. When you add up all the resources, here's what the overall resource schedule looks like. You go from 2 people to 5 people to 4 people, etc. And there your project ends at 12 days, which is what your network diagram arrived at. But let's say you don't have that many people. Let's say you don't have a peak of 5 people or 4. And also notice this is very unbalanced. You go from 2 to 5 to 4 to 1. Let's say you only had 3 people available. What happens? Well, now you have to start going one by one through each of these activities in your network diagram, and then pushing out, assigning some activities and then pushing out others that can't be scheduled. For example, activity 1 was scheduled first. That had 0 slack. Okay, now what do you do next? We look at slide 14. We scheduled activity 1 first. We had a choice of scheduling 2, 3, or 4. What is done here? We scheduled 2 first. We delayed 2 and we scheduled 3 and 4. Why did we schedule 3 first? Because it had less slack. It was on the critical path. But by shifting out activity 2 by 1 day, we've removed a day of slack. So this process is what you do throughout the project as you apply resources to activities. You look at the activities as scheduled, then you look at the rules of thumb. Which one should I schedule first? You schedule the ones first with the least slack, second with the shortest duration, or third with the lowest activity number. This is why activity 2 was scheduled first. If you schedule that first, that means other activities are going to have to be pushed out as a result, and this is what's happened in figure 8.16. And notice that you continue to push out activity 2 because you only have a maximum of 3 people you can apply at any given time to this schedule. And so in this example, we walk through this entire process of looking at each activity, applying resources based on the priority of the rules of thumb, lowest slack, lowest duration, smallest activity number, until we get to the end. What happens at the end? The entire project ended up shifting out 2 days. And they shifted out 2 days because we didn't have up to 5 people as we originally needed. We only had a maximum of 3 people. So instead of 12 days, we ended up at 14 days. So this is the basics of this week's lesson. That number 1, you typically don't have the resources you need, and because of that, you're going to have to shift around and reprioritize some of your tasks. As you do that, you use up some of the slack you originally identified. You want to schedule, assign resources to the most important task first, which are those with the least slack. But at the end of the day, you end up using up slack. You end up changing the critical path because, like for example, if you see here in Figure 8.5, now you have 2, 3, 5, and 6, and 7. All of these are on the critical path, and they were done that way because their slack was used up because of a lack of resource availability. And then finally, remember that it's important to balance resources. You don't want to have peaks and valleys in your resource demand. You want to smooth out resource demand so you can avoid heavy peaks. And also you have to consider the morale of your people as well. As if someone had to work 80 hours one week and none the next, and then 80 hours the next week, that's not very healthy. So this is all about resources and applying resources, what it does to the beautiful schedule that you had up to now and how it changes things. And then finally, last thing to remember is there's cost associated with the resources. So once you apply resources to a project, the cost is applied to the project as well. So you now have a means to really understand how much your project is going to cost you once your resources are applied. Okay, so let's move on to WBS 6, and I'll see you in the discussion threads this week.